guys, I'm Mrs. Raposa, and I'm going to be going over with you how to find limits of piecewise functions. So hopefully you have your note packet in front of you, and I'm going to jump right in and start with problem number 1. So problem number 1 is asking me to find the limit as x approaches 1 of f of x. So the first thing that I notice is that my function is a piecewise function, which means that there's 2 pieces. And where the function splits is at the number 1. And so because that happens, I have to be finding the limit from both sides. Remember, in order for a limit to exist, I have to come from the left and come from the right. So I can set up the limit as x approaches 1 from the left and the limit as x approaches 1 from the right. And as long as I get the same value, that value is going to be my answer. So we have to decide which one to use. Well, from the left would be numbers that were smaller than 1, or x is less than 1. So from the left, in this case, I'm going to use the top function, 1 minus 2x. And I'm going to go in and substitute 1 in for x and evaluate. So if I find that limit, I have 1 minus 2 times 1. I have negative 1 being my answer. Then I'm going to find the limit from the right. From the right would be numbers where x is greater than 1, or the bottom function. So please make sure when you're writing this out that you use good notation and that you're actually putting the function x minus 3 there. So to find this limit, I'm just going to take 1 and I'm going to sub it in for x right there. So it's going to be 1 minus 3, negative 2. And then in order for this limit to have an answer, I have to compare the left and the right limits. And the first thing that I notice is that these are not the same value. So because they're not the same value, this limit does not exist. It would have to be the same number from the left and from the right. Okay. Let's try problem number 2. It looks pretty similar. And we're going to find the limit as x approaches 4. So again, I'm noticing that 4 is where this piecewise limit splits. So I'm going to have to do the same thing I just did. I'm going to have to find the limit as x approaches 4 from the left and the limit as x approaches 4 from the right. And if I get the same value, that will be my answer. This time, from the left happens to be the bottom function. X is less than 4 would be numbers from the left. So I'm going to write that function here, 8 minus 2x. And then I'm going to evaluate the limit. So I'm going to take 4 and sub it in for x. So I have 8 minus 2 times 4. 8 minus 8, and I get 0. Then I'm going to find my limit from the right. From the right, I'm going to use the top function because it says use the top when x is greater than 4. So I'm going to recopy the function, the square root of x minus 4, and I'm going to sub 4 in to find my limit. So I have the square root of 4 minus 4, which is 0. And then we compare the left-hand limit with the right-hand limit, and this time they're the same. So because I got the same number coming from the left and coming from the right, that number 0 is my answer. Okay, let's try problem number 3. It's a very similar. Problem number 3, x is approaching 1. And 1 is where this function splits in the piecewise function. So I need to find my limit from the left and from the right. Let's set it up. Lim as x approaches 1 from the left. Lim as x approaches 1 from the right. From the left, we always want to use numbers that are less than 1, which would be, in this case, the top function, 1 minus 2x. To find my limit, I simply take 1 and sub it in. So 1 minus 2 times 1, and I get negative 1. Let's find our limit from the right. From the right, I'm going to use the bottom function because x is greater than 1. So x minus 3. I'm going to substitute in to find my limit. So 1 minus 3, and I got -2 this time. And so I'm noticing that these two are not the same. Remember, they have to be the same from the left and the right. And so this problem, this limit would not exist for number 3. Okay, and you can pause the video if you need to go slower. Let's take a look at problem number 4, and you might guess it's the same idea. X is approaching -1, and notice that's where my limit's splitting, or my piecewise function is splitting. And so I'm going to have to find my limit as x approaches -1 from the left, and the limit as x approaches -1 from the right. Make sure you're using good notation as you take your notes. -1 from the left, those are numbers that are smaller than -1. I'm going to use this top function, x plus 2. And all I'm going to do is take -1 and substitute it in. So -1 plus 2 gives me 1. And then I'm going to find the right-hand limit. For the right-hand limit, I'm going to use the x is greater than -1 function, which is x squared. And I'm just going to take -1 and plug it in. And be careful when you do this. In for x, you're putting in -1, and the entire x is squared. So -1 squared is 1. And my left-hand limit is 1, and my right-hand limit is 1. And because they are the same number, the answer to the problem is going to be 1. So that's how you would approach a piecewise function that had a less than and a greater than sign, where it splits at our x value. Problem 5 and 6 are a little bit different. So problem 5 is piecewise, but it does not say less than and greater than. It says does not equal and equal. And so we might say, okay, well, how do we do this? Well, I want you to think about how we evaluate a limit for a moment. This question is asking us, what is the limit as x approaches 1? Well, what we know is that when x is 1, my y value is pi, which is about 3.14. So I have a dot or a point right up here. And then the other thing that I know is that when x doesn't equal 1, I'm following this equation, x plus 1, which looks like this. It's going to have a hole, but it's going to be a line that looks like this. Now, if I gave you that graph and I said, look at that graph and tell me what is the limit as x approaches 1, you could probably at this point say, well, the limit as x approaches 1 is 2, because a random dot can never be the answer to a limit. The open circle can be the answer. Therefore, when we're doing it we don't have to graph it. When we are doing a limit and it is piecewise, and you have the choice to use the does not equal or the equal, we're going to pick the does not equal, because we don't really care what's happening exactly at 1. We care what's happening coming from the left and coming from the right. So we would do this. The limit as x approaches 1, we would use the function next to the does not equal. And then I'm going to sub 1 in. And I get my answer of 2. So when given the choice, always choose the function next to the does not equal when you're evaluating a limit. Okay, number 6 is very similar to number 5. I'm not going to graph it. Number 6 says find the limit as x approaches 1. Well, I have a does not equal and an equal. I'm going to use the function next to the does not equal. So I'm finding the limit as x approaches 1 of just 4, just the number 4. Well, that's kind of weird because there's no x in there, so there's nothing to plug in 1 into. And so since there is nothing to plug 1 in, the answer is just simply 4. Okay. Last up, number 7 says find k such that the limit as x approaches 3 of f of x exists. Okay. So we have to figure out what k is, and we need for the limit to exist. Well, remember, for a limit to exist, the limit as x approaches 3 from the left must be equal to the limit as x approaches 3 from the right. If those two limits are equal, then the limit exists. So let's figure out which function to use where. From the left, we're going to use numbers that are less than 3. So we're going to use 3x minus 1. And from the right, we're going to use numbers that are greater than 3. So we're going to use the function 2x plus k. And these limits have to be equal to each other. So to find the limit, I'm just going to sub 3 in. So 3 times 3 minus 1, 9 minus 1, I get 8, needs to be equal to the limit over here when I plug 3 in. So 2 times 3 plus k, we still have a k, 6 plus k. And then all we have to do, remember the directions said find k, so our goal is just to find k. If I subtract 6 from both sides, I get that k equals 2. Okay, please remember that in addition to taking these notes for the asynchronous day, the other thing that you have to do is you have to take your quiz. So on Schoology, there is a quiz. You need to go into there, into Schoology, and take your quiz. And enjoy the rest of your day.